Last section of chapter 7, section 7.7 is on modeling with trigonometric functions. Example 21, we know all about modeling, so application of your maths in real life. So here we've got the cabin pressure P, which is measured in pounds per square inch on an aeroplane at, it's PSI by the way, the units, see, PSI, on an aeroplane at cruising altitude can be modeled by the equation 11.5 minus 0.5 sine t minus 2, where t is the time in hours since the cruising altitude was first reached. Okay, so once you've lifted and reached the cruising altitude, that is the time that we begin measuring everything else from, the cabin pressure from. Okay, angles are measured in radians. State the maximum and the minimum cabin pressure. So you need to find the maximum and the minimum cabin pressure, so the maximum and the minimum of P. So this is like bounds. So if you think about sine function, sine at its lowest is -1 and at its highest is equal to 1. So if you make sine equal to, so if sine t minus 2 is at its lowest, what will happen to P? P is going to be 11.5 minus 0.5 times -1. So that gives me 11 plus a half, so it's 12. Now, if sine is replaced with its maximum possible value, because that's the only part of that equation that varies, and its highest value is 1, P will be 11.5 minus 0.5 times 1. That gives me 11 PSI. There you go. So that is the maximum value and this is the minimum value. And you've been asked to find both. Find the time after reaching cruising altitude for part B that the cabin first reaches a maximum pressure. So when will it reach 12? How about making P equal to 12 and substituting this value into this equation? So it's 12 is equal to 11.5 minus 0.5 sine t minus 2. So it's going to be 0.5 sine t minus 2 is equal to minus 0.5. If you move 11.5 across here, that will become 12. Take away this, which is 0.5, but then the minus, if you swap the minuses. So sine has to be equal to -1. We know that anyway from this, so just confirming it. So when is sine going to be equal to -1? Well, if you think about doing the sine inverse of -1, you can also refer to your graph of sine function. There you go. This is going to be at 3 pi over 2. But because you are got transformed graph, you need to be very careful, because you also will reach -1 at minus pi over 2. So let's consider that value as well, because you are shifting by -2, so the range of values not start from 0. So if t was, let's say, measured from 0 to 2 pi, our t minus 2 needs to start from -2 radians up to 2 pi minus 2 radians. And minus pi over 2, it's half of 3.14. It's going to be between, it will be within the range of values for which we are solving. So t is equal to 3 pi over 2. Let's add the 2 to that for my first value, and then minus pi over 2 plus 2, that's for the second value. So this one here, if you work out this, I haven't got a calculator, that will give you 26 minutes, because this is going to be 0.43 hours. And this one here, okay, pause for the calculator, got it there. And let's just prove to you that it's still going to happen at that time, but it's not going to be the smallest possible value. So let me just check that I'm in radians. Now I am. It's 1.5 pi, which is 3 over 2 pi, plus 2. That gives me 6.71 hours. Now, if I want to change it into minutes, I press that key. That gives me 6 hours and 42 minutes, 44 seconds. 44 seconds will round up to 43 minutes. And then check that you get 26 minutes if you've got minus pi divided by 2, which is this, plus 2. That gives me 0.429 hours. Converted to minutes, it's going to be 25 minutes and 45 seconds. 45 seconds round to that number to 26 minutes. So 26 minutes is going to be reached before 6 hours 43 minutes are going to be reached. Probably won't, the plane is not going to be flying it for much longer actually. Don't know how long the flight is. Okay. Part C, calculate the cabin pressure after 5 hours at a cruising altitude. So this is simply making your T equal to 5. So P is equal to 11.5 minus 0.5 sine 5 minus 2. So that's going to be, put it into the calculator, 11.43 psi. Not sure why they've gone for 2 decimal places. No pressure is given in that. I would probably go for 3 significant figures, to be honest. But if in doubt, leave all the decimals first and then do the rounding. And then find all the times during the first 8 hours of cruising that the cabin pressure would be exactly 11.3. So we are going to do P is equal to 11.3. So replace P with 11.3 in the equation and just solve that trig equation. So we're just applying our methods that we've practiced before. So 0.5 sine t minus 2, if I move that one across here, this is going to be 11.5 minus 11.3. So sine t minus 2, we can work it out to be 0.2 over 0.5. T minus 2 is equal to sine inverse 0.2, 0.5. Again, if you going to work from, you've got to allow your range of values for t, such as time, to be shifted. So you're going to make sure that you start from minus 2. Obviously, you've got to go up to more than 6, obviously, well, up to 6 for 8 hours period, but if you go further, that's okay, and then just pick the ones that will take you up to 8 hours. Okay, so let's do sine inverse, so in radians, 0.2 divided by 0.5. Okay, this gives me 0.4115. The next time for sine, remember the sine graph. You have the first value, the second value is going to be pi minus that. Okay, I've shifted it to minus 2, but I could see that there is no value at minus 2. It's going to be sine negative, and we've got 2 over 5. So t is equal, let's add 2 to that, 2.4115, and then 4.73. So if you add 2 to this one first, that's going to give me 4 hours and 44 minutes. and this one 2.4115. If I change it into this one, it's going to be 2 hours 24 minutes. There you go. There's no other values, so let's just check. Oh yeah, 25 minutes. That's good spot. Okay, even mine rounds nicely here, and this is correct. So 4 hours 44 minutes and 2 hours 25 minutes. So you're ready now to go ahead and do exercise 7G and then mixed exercise.